Welcome to physics chapters. Now let's solve this problem 2. And this problem is based on the first application of the dimensional equation, which is to check the correctness of a physical equation. So here the given equation is P plus A upon V square multiplied by V minus B is equal to RT. Here P is the pressure, V is the volume, R is the ideal gas constant, T is the temperature, A and B are constant. Here we have to find the dimensions of constant A and B. Let's see how we can find the dimensions of A and B. And to solve this type of the equation, we have to remember we always add or subtract physical quantities having same dimensions. Like we always add volume with volume, and what we will get volume only. If we subtract volume, we can subtract volume, and volumes will get volume only. If we cannot add acceleration and length, this is not correct thing. Okay, so we always add or subtract same physical quantities, and this is the thing we are going to use to solve this question to find the dimensions of constant A and B. We know that we always add or subtract same physical quantities. So here if we see this P plus AV square, it means that this is our pressure, and this should also be a pressure because we can add pressure with pressure only. So it means A plus V has the dimensions of pressure. So from here the A is equal to pressure multiplied by volume V square. Now we'll write the dimensional formula for the pressure. The dimensional formula for pressure is M L minus 1 T minus 2, and for volume it is L cube raised to power 2. So this will become M L minus 1 T minus 2 L raised to power 6. So which is equal to M L raised to power minus 1 plus 6 T raised to power minus 2, which is equal to M L raised to power 5 and T minus 2. So these are the dimensions of A. Now let's see what are the dimensions for B. So here it is V minus B. So it means we can subtract. I have told you that we can subtract same physical quantities. So this B will have the dimensions of volume. So it means that we have the dimensions of L cube. The dimensional formula for B is L cube, or we can write this as M raised to power 0, L raised to power 3 and T raised to power 0. Now let's do one more question related to same concept. So in this question we have to write the dimensions of A and B, and this relation is E is equal to B minus x squared divided by AT. Here E is the energy, x is distance and T is the time. So if we see this B minus x square, we know we always add and subtract same physical quantities. So it means the x and B have same dimensional formula. So this B has the dimensions of x square. So the dimension of x is L raised to power 2. So the dimensional formula for B is M raised to power 0, L raised to power 2 and T raised to power 0. Now we have to find the dimensions of A. So this whole thing, when we subtract volume with volume, we'll get volume only. So it means when I subtract B from x square having the dimensions L square, so this whole quantity will be equal to L square. So here we can write A is equal to B minus x square divided by E multiplied by T. Now we will write the dimensions of all physical quantity. The dimensions of B minus x square are L square divided by the energy. The dimensions for energy are M L square T minus 2, and for T it is T. So this is equal to M will go up m raised to power minus 1, l raised to power 2 minus 2, t raised to power 2 minus 1. So this is equal to m raised to power minus 1, l raised to power 0, t raised to power 1. Therefore, is m raised to power minus 1, l 0 and t 1, and the dimensional formula for b is equal to m0, l2 and t0. In this problem, you have to find a divided by b, and the given relation is f is equal to a square root of x plus b multiplied by t raised to power 2.